The nemesis of many science students is trying to figure out the number of significant figures, or sig figs for short, in a number, or after doing math, how to figure out how many they should keep in their answer. I'm going to address the second issue in a second video. So this one we're just going to talk about how to look at a number and figure out the number of significant figures in it. The only thing you really have to worry about are zeros. So if you have a number like this with no zeros in it, all digits are significant, so that would have 4 sig figs, 4 significant figures. So a number like this would have how many? 5 sig figs. There's only one type of zero that we need to worry about. If the zero is in the middle of the number, we don't have to worry about it. It has a non-zero in the front of it, a non-zero in the back of it, so we just count them all. The problem that you run into is when you have zeros in the front or the back of a number. Here's a big number that's ending with a whole lot of zeros. Now the problem is we don't know, was it measured to the ones place, or was it measured to the closest tens place, or the closest hundred, or the closest thousand? We know it was measured to this spot because there's a digit there that's not zero. So we know that these two were actually measured, but we don't know how precise the instrument was. So we only count these 2 digits. So this would have 2 significant figures. And we ignore all those. We have to keep them because you need to keep your distance from your decimal point to make that 450,000 and not just 45. So we still have to keep those, but the only significant ones, the only ones that we know have meaning, are the first 2. All right, what if we have a number like this? We know the 1, the 2, and the 5 are significant because they're not zero. We know that zeros between significant digits are also significant. So there's no way to measure this location without having measured to that location as well. So this one would have 5. These 2 are called place holding, just like these 4. These are called place holding zeros. You need them there because you need to hold that distance from your decimal point, but you don't know, was it measured to the closest tenth, 10 or 1? You don't know. So this would have 5 significant figures. So the only zeros you have to worry about are these place holding ones at the very end of large numbers. Let's look at some small numbers. When looking at a small number, our place holding zeros are here in the front instead of in the back. And remember, we don't count those. So these, while we need them to hold our distance from our decimal point, we need them in the number, but we don't include those in our count. So this would have 2 sig figs. Another way to think of this, which might be easier if you know how to do scientific notation, if we put this number into scientific notation, we would put 3.4 times 10 to the 1, 2, 3, 4, and we moved it to the right, so -4, negative exponent for small numbers. And notice that the only thing we can show are these 2. There's no way to show those zeros. Like, you wouldn't write a number with zeros in the front like that. That's crazy beans. So we wouldn't show that. So Think about if the number goes into scientific notation, that's why only these count. So 2 sig figs. You can pause the video and see if you can figure out how many sig figs and start it again when you're ready to check your answers. Sig figs. Our first number has 2 placeholders. We keep the 3 and the 1 because they're not zeros, and any zeros caught between significant digits are also significant. So that has 3 sig figs. Our next one, we have a significant one, a non-zero in the front, and a non-zero in the back, so we count them all. 4 sig figs. So if you check the beginning and ending of a number, if they're both significant, the whole number is. Our next one, we have this one and this one that we know for sure are significant. This one is because it's between 2. And this one is because why in the world would we put that unless we had actually measured it to that precision? So this one has 4. This front one is a placeholder. And this front one is just optional because you could have written the number like that. Our next one, these are all placeholders. We started our decimal and we go across till we hit something that's not a 0, and then we start counting, and we just keep counting for however many digits we have. So this one has 2 sig figs. I hope this has helped. I'm going to do a separate video on how you do math with sig figs, the rules for that, and how you figure out how many significant figures you should have in your answers. I hope this helped. Please like and subscribe.